Hello, dear students. Good morning. In the last period, we have studied about the various classification of colloids, and we have also seen the um, mechanism of cleansing of clothes. So, so mechanism for the cleansing of detergents and mechanism for the cleansing of soap, and now we'll see the various methods for the preparation of colloids. There are various methods for the preparation of colloids. First of them is chemical method. In this chemical method, colloidal solution can be prepared by chemical reaction leading formation of molecules by either double decomposition or oxidation or reduction or hydrolysis. These molecules then aggregate leading to formation of salt. So we just perform a chemical reaction. Due to chemical reaction, some particles or precipitates are formed which aggregate and make the salt. For example, you have As2O3, that is arsenic oxide, which reacts with H2S gas to produce As2S3 salt. Same way, this is what it is, the double decomposition that you can easily understand. Then you have the oxidation. This oxidation, you can even say this is double displacement. Sulfur dioxide reacts with H2S gas and it produces the sulfur particles. These sulfur particles again they aggregate themselves and make the colloid. By the reduction, you can see that EuCl3, that is gold chloride, reacts with HCHO, that is your and water. This is what it is, your ethanol. So ethanol is converted to ethanoic acid, but your gold Eu plus 3, this Au plus 3 is converted to Au0, that is the Au metal, and these metal particles they aggregate themselves and produces the salt. Same way you can see here the hydrolysis. This is what it is, FeCl3, and this FeCl3 is added to water. So FeCl3 produce the precipitates of FeOH thrice. These precipitates, due to the various charges available because of this, FeCl3 is an electrolyte, so it converts itself into the Fe plus 3 and 3Cl minus. These Fe plus 3 ions are adsorbed on the surface of these precipitates of FeOH thrice, and these precipitates they are broken into the colloidal size particles due to the repulsion between the positive charged ions, and this is how the FeOH3 salt has been produced. This particular process is also known as peptidization. We will study it in later, but this is how the FeOH3 salt can be produced. You must have observed that using these chemical reactions, we have prepared the As2S3 salt, sulfur salt, gold salt, and FeOH3 salt. Now we have the second method. This method is known as the electrical disintegration method, which is also known as the Bredig's arc method. This process involves the dispersion as well as the condensation. So colloidal salt of metals such as gold, silver, and platinum can be prepared by this method. In this method, electric arc, electric arc is struck between electrodes of the metal immersed in the dispersion medium. So you can see here, see these two are the metal rods. These metal rods are joined with the electricity, or you can say the battery from where the power supply is available. Here you have an ice bath. In this ice bath you have a beaker or a vessel. In this vessel dispersion medium is filled. Now when we pass the electricity and we bring together, or we bring this electrode near to each other, there is an electric arc produced between these two electrodes, and due to this, immense amount of energy is being produced, and this energy makes this metal to turn into the vapor, and when it is turned into the vapor, it goes inside the dispersion medium. It itself is condensed, and due to condensation, the colloidal sized particles of this metal is being produced. So this is how we can prepare the colloid. The same I have written here. The intense heat produce vapors vaporizes the metal, which then condense to form the particles of colloidal size. Then we have the next method, which is known as the peptization. Let us read or understand the definition of peptization. The process of converting precipitates into colloid by shaking it with dispersion medium in the presence of small amount of electrolyte. We have just seen this method, that you can easily understand here that this FeCl3, when added to water, it produces the FeOH thrice sol, FeOH thrice precipitates. There is a presence of FeCl3, which is an electrolyte. It behaves as a peptizing agent. From this FeCl3, Fe plus 3 ions are produced. These Fe plus 3 ions are adsorbed on the precipitates of FeOH thrice. Due to this, these precipitates of FeOH thrice are broken into the colloidal size due to the repulsion between the Fe plus 3 ions. And this is how the sol is produced. This particular process is known as peptization. In peptization, we have peptizing agent. So let us understand what is peptizing agent. The electrolyte used in the process of peptization is called peptizing agent. So here we have just seen that FeCl3 can be considered as a peptizing agent. This method is applied generally to convert freshly prepared precipitates into sol or in a colloidal sol. Now what happens during the peptization? During the peptization, precipitates adsorbed on one of the ions present into the electrolyte, that is present into the peptizing agent, on its surface, which causes the development of positive or negative charges on the precipitates, which ultimately break up into the smaller particles of colloidal size. Example, the first example is the precipitates. We'll see the example into the next video. Happy learning.